Hey, Miss Sparks.
Hey, Adriana, how are you?
Good, how are you?
Pretty good.
Cool. Still on here?
Um, the questions that were emailed to me, I'm going to start with those first. So I'm going to start on the 8.5 worksheet and work my way backwards,
Cool.
all the way to parabolas if we have to go there. It just depends upon, who shows up and
Okay.
who
Campbell.
has questions and all that good stuff. So if nobody else but you shows up, and if you will, just let me know if somebody else does, because I can't really.
Yeah, Campbell's here too, so.
Oh, hey, Campbell. So if and just what I did or what I posted in the lesson plan or what I thought I posted in the lesson plan. Maybe I didn't. I'm just if I'll just set this out there. If one of you two want to type it in the chat for me, if people will just write down their questions, I'm going to start with 8.5 worksheet and work my way back to 8.2. So the questions that were originally emailed to me, there were none that were emailed to me about the actual graphs. So I'm going to go on down to number 5 and start there. Unless, Campbell, do you want something with the graph on 8.5?
I just had like some questions about the parabolas.
Oh, it's about the parabolas.
Yeah,
okay.
The rest of the graphing I can get, but just the parabola graphing was like difficult.
Okay. All right. I had these emailed to me first. So let me start on 8.5 and then I'll actually just go ahead and skip to 8.2 and then come back to 8.4.
Okay.
Is that okay with everybody?
Mm-hmm.
All right.
Walker joined.
Okay. Hey, Walker. For number 5, what we on a hyperbola, the key thing to remember is that the vertice is always going to direct or dictate the direction that the hyperbola opens if you're graphing it, and it also dictates which of the two variables happens first in the actual equation. So in this case, the vertice is 0, 12, or the vertices are 0, 12, and 0, negative 12. So they're in the y coordinate. So that means the y is going to be the first variable in your equation. And fortunately, like Miss Stone and I said, we're all of the conic sections that we're going to be dealing with this year are going to have a center of 0. So you're not going to have to worry about the y minus k part here. You're just going to put y squared because we know it's 0, 0 as the center. And then what you'll do is you'll take the vertice value, which is 12 in this case, and you'll square it because that's going to be your a squared. So that's going to be 144. And the standard equation of a parabola is y squared minus x squared or x squared minus y squared, depending upon the vertice. Once again, I reiterate that the vertice is what dictates which direction the graph opens and also which variable drives that first slot. And it's always equal to 1. So the second part is x squared, and what we're missing is this b squared value. We don't know what it is, and that's what goes underneath the x squared. And basically, you're using the Pythagorean theorem to find out what that value is, and it's telling us our foci is 13, so that's your c squared. So we have 169, which is 13 squared, equals, and then our a value in this case is 12 squared or 144 plus b squared. So I'll subtract 144 from both sides. And that's going to give me 25 equals b squared. And so that's going to fit right under here. So now I have all of the information that I need to write the equation in standard form of this hyperbola. So it's y squared over 144 minus x squared over 25 equals 1. And then for number 6, the vertice is 5, 0 and negative 5, 0. So that tells me that this hyperbola is going to open horizontally, and my x is going to be my first variable. And I would take 5 squared, which is 25, and then minus, and my covertice, which is going to be y in this case, is going to be over b squared, which is missing. And in order to find that value, I'm going to take the foci, which is 13 and negative 13, and square it, which is 169. And then my vertice is 5 squared, which is 25, plus b squared. I'm going to subtract 25 from both sides. It's kind of nice that my figures are pretty much the same in both of these. 144 equals b squared. So that's going to fit underneath here, underneath my y. So now I have enough information to write the equation in standard form. Hey, Mo or Bill, would you mind finding Finn a different toy while I'm in math lab? Sorry about that, guys. Okay. I believe that those were the primary questions that I had, except for 9 through 12 on these. And I know one of these kind of addresses Campbell's question as well about the parabola. So I could go ahead and do 9 because that is a parabola. Is that okay with everybody? Campbell, will that help you out?
Sure.
Okay. Okay, on the parabola, the things that we learned about this time were the directrix and the focus. That was something that was different that we hadn't learned before with regard to parabola. We're kind of used to the quadratic equation, the quadratic formula to solve for the x-intercepts and finding the solutions to that, and the vertex and the axis of symmetry. Those were things that we had learned about prior, like in Algebra 1, and actually I think we've even discussed them earlier this year. The new things that had to do with the parabola now were the focus and the directrix. Everybody was kind of familiar with the vertex, but in this case, this is y equals x squared, and we were supposed to identify whether it was a parabola, a circle, or a hyperbola. And in this case, since there's only one squared variable, I know that it's a parabola. So that's how you know that. If there's more than one squared variable, it's going to be another conic section. If there's only one, you know it's a parabola. The next thing, in order to find out, the other thing that I know is there is no y, like for y, this would normally be like a y minus k equals x minus h squared. And since there's literally no k or h, I know that the vertex is 0, 0. So the other thing that I know is this is almost in a vertex or a transformational equation format. So that essentially is going to say that x squared equals 4py. Do y'all remember that? Or is that the part that seemed to be a little confusing to you guys?
Yeah, I struggle like so much with the P stuff.
Okay.
Yeah.
Okay. So we've got, basically, it's always easier for me, and I do this to get that squared term on the left. That, for me, that's just easier. It doesn't really obviously make any difference, but when I look at it, that's a little easier for me. So when I look at this, the best way to maybe explain this is that if you have our formula and it looks like this, kind of rewritten, this is the same thing as that right there. The only difference between this and this is this part right here. Would you agree? That 4p, the only thing that's really missing from this formula is that 4p.
Yes, ma'am.
Does that make sense?
Mm-hmm.
Okay. So what is understood in front of that y?
4P.
In this
one.
one here, but what would be understood here?
1.
1, absolutely. So would you agree with me that if I have x squared equals 4py and I have x squared equals 1y, that 4p in this case needs to equal 1? Does that make sense to you?
Mm-hmm.
Like I'm substituting basically for this to be here.
Yeah.
So to solve for p, what would I do?
Divide by 4.
Divide both sides by 4. So p has to equal 1/4
Okay, I got that.
in this case. Okay, so that means that the focus, because it's an x squared, is going to be 0 1/4. And so, and there's like almost no way that I'm going to be able to get that graphed on this thing. I need like.
So if it's in the X, then the focus is in the Y and vice versa?
Yeah.
Yes, ma'am.
Okay.
That is it. Absolutely. Because the focus and the directrix, well, mostly the directrix, because the directrix now is going to be y equals negative 1/4. Because it's the exact same distance in the opposite direction, but it is basically a line that runs like this. Does that make sense? And it runs perpendicular to the axis of symmetry.
Mm-hmm.
Like that. Then I just kind of do a couple points, which I know, 1, 1 is 1 and 2, 4 is 1 for this particular one. Because that's just an easy parent graph that we're used to. But whatever, I guess, Campbell, the best way to say this, and it's going to be the opposite of this one. So if I flip this, x squared equals negative y, then this right here is the same as negative 1. So that tells me that negative 1 equals 4p in this case.
Okay.
So if I solve for p, I'm going to divide both sides by 4. And this time, p equals negative 1/4. So once again, this is going to be
So we're only finding the focus?
Yes, in this, it's asked to find the focus and the directrix and the vertex, which it's pretty easy because what Miss Stone and I have done is the origin's always at the center. So you've got the center already. So you're really, when it comes to a parabola, we're just looking for the focus and the directrix because there's no vertices or co-vertices in this because there's only a singular vertex.
Okay.
And so you're only going to be dealing with this 4p, or in some cases, you're going to actually plug in a value. I think that happens on the last page of this overview. But on this, you've got 0, -1/4 as your focus. And then you've got y equals a +1/4. So actually the complete opposite of what number 9 was is number 10.
Yeah. Okay.
Okay. All right. And then I'll go back and do a few more examples of like when you're given the directrix in the focus in just a minute when we go address the parabolas on that particular worksheet. Okay.
Okay. Do you mind doing a few of them on the back page?
Absolutely not. I don't. And I was going to do, I felt like I got an email that said number 11 and number 12 as well. But I can promise you those are circles and you all are not allowed to laugh at my circle when I draw it because it is ugly badly. But anyway, on a circle, when it looks like this, the x squared y squared basically tells me right away that my center is at the origin. So, and then the other thing is I take the square root of this and that's my radius. So on this, it didn't even ask for a radius, but that's the only other piece of information that you can really give other than center on a circle. So on my paper, I wrote center is 0, 0 and radius is 7. And then I sketched the graph. I sketched my ugly circle by plotting my 4 points. And then I pray and I make an ugly circle. So there it is. Was that one wasn't one, was that, let's see. And then on this right here, I'm going to take the square root of 28 and approximate it. And I believe it's 5.29. And so that's about right there. Right there, right there, and right there. And this is the radius right here, and the center is 0, 0. Okay. Now, my ellipses are as equally as ugly, but these are both ellipses right here. And how I can tell that is that the end is equal to 1 and the middle operation is plus. So if you'll just kind of look with me at number 13 and 14 and 15 and 16, there are similarities that they're both equal to 1. So when they're written like this, I can deduce that they're either going to be an ellipse or a hyperbola when it's equal to 1. And then to narrow it down even further, I'm going to look at that middle operation. And if the middle operation is addition, then I've got an ellipse. If the middle operation is subtraction, I have a hyperbola. Does that help?
Yep.
Okay. All right. So for these, I talked about this a little bit in class. I'm going to emphasize this again. That the bigger number is what tells you what the major axis is or the vertice. So the vertices in this particular case, the larger one is a 49. So my vertices, I'm just going to write a V. My vertices are going to be on the X axis. So it's going to be my major axis. And the vertices are plus, minus 7, and 0. And the reason why I know, once again, we're dealing with the origin. So I know that it's going to be plus or minus 7 away from the center. That's how you know what the vertices are. The co-vertices are going to be plus, minus in the y direction of 4. So along my x-axis, I'm going to plot my 7s. And the y, I'm going to plot my 4s. And then I'm going to make my ugly ellipse.
Question, are vertices always in the X and co-vertices always in the Y?
No,
Depend.
they are not. The vertice is always in the larger, whichever one the larger is. On number 14, my vertice is going to be in the Y because the bigger one is in the Y.
Okay.
But that's on ellipses. That's only on ellipses. The ellipses are the only one where the value is the important one. On the hyperbolas, the vertice is going to be in the first term. Its placement in the equation is what makes it the vertice.
Okay.
It is it's the value that makes it the vertice in an ellipse. Okay, so value in the ellipse, placement in the hyperbola.
Okay. Sorry if y'all can hear stuff in the background. Kylie's playing Mario Kart and it's really loud.
Oh, okay, I couldn't hear anything.
Okay, well, never mind. It was so loud.
Oh.
My bad.
Is she winning?
Are you winning? Yeah, she's winning.
Good. Okay. All right. So vertice and covertice on this ellipse. And then the last thing that we were asked to give was a foci. And the foci for an ellipse. Does anybody remember the equation? It is different than the hyperbola. It's a minus. So if you want to think about the ellipse, the fact there's an addition in the original equation or the standard form of the equation, and then when you're trying to find the foci, there's a subtraction in the non-Pythagorean theorem that has the same letters as the Pythagorean theorem, but it's not Pythagorean. But what you'll do is you'll take your 49. Which is your A, your larger one, and subtract your B, your smaller one, or your covertice from one another. And whatever that value is your C squared. And that's going to be 33 in this case. I already had written down what the square root of 33 was, because that's going to be your foci, is going to be plus minus, and your foci are always on your vertice axis, whatever that is. And in this case, it's the x-axis. So it's plus minus 5.70. And I do plus minus because it's going to go both directions away from the center. Does that make sense to you guys?
Kind of. Emily McGinnis said yes. So
Okay. But kind of. Okay. When you're dealing with, okay, if the 0 wasn't the center, it would be plus or minus 5.7 away from the center.
So it's always, why is it in the X though? Because it's got to be in the inside?
It's got to be for the ellipse, it has to be on the major axis.
Is the focus always on the inside of it though?
Oh, yes. Yes, I'm sorry.
Okay.
I apologize. I understand what you're saying. Yes, it's always on the inside of it. So if you end up with a focus that's on the outside, you put it on the wrong axis.
Okay.
But so that's why usually you'll know that it's going to be on that major axis, because a lot of times it's going to fall outside the minor axis. So you're like, oh, I'm not putting it on the right one.
Okay.
But the foci always follows the vertices.
Okay.
Not the covertice. Okay, so on number 14, it's 2. So the vertices are going to be the larger one. It's going to be on the y-axis, and the vertices are going to be 0 plus minus 3. Do you understand where I got that?
Yes, ma'am.
Okay. Is anybody questioning that?
No, ma'am.
Okay, nobody said, okay. I just want to make sure if anybody has a question, stop me.
Okay.
Okay, and my co-vertices are going to be plus, minus 2, and 0. So I have to find then my foci, which are going to be 9 minus 4. So c squared is going to be, actually, that's c squared is actually 5. And c is the square root of 5. So my foci are going to be in the y position. Do you understand why?
Yes, ma'am.
And it's plus minus 2.2. Sorry. So the foci are right there. And once again, this is really hard to draw because they're very, very close to my, and this is an elongated ellipse. And that's not a very pretty one, I admit. Any questions on those? Everybody feeling good about that?
No, there are no questions.
Okay. All right. So on this one, we're working with hyperbolas now. We've got the equal one, but we've got the subtraction sign in the middle. And on this one, different than the ellipse, is it's not the value that drives the vertice, co-vertice. It is the position. So whatever position, whichever is in the primary position or that first position, that's going to be where your vertices are. Okay. And it's also going to dictate which way the hyperbola opens. So in this case, the y goes first. So my vertices are going to be 0 plus minus 2. And my co-vertices are going to be plus minus 4, 0. And it is going to open vertically. So I would go, I'm going to go ahead and graph my vertices and my co-vertices. That's going to be the first thing that I'm going to do. And then I'm going to draw that sweet little rectangle. Okay. And then those wonderful little asymptotes that are very hard to graph. They go through the corner of the boxes and through the center. And then my foci on this one is the Pythagorean theorem. So I've got 4 plus 16. So that's 20. So c squared is 20. So my foci is 4.5. And somebody double check me and make sure that that is the square root of 20. I think it is, though. I'm guesstimating.
Let's see. Yes, ma'am, it's 4.5.
Okay. So your foci are, once again, much like the ellipse, it is on the inside of your hyperbola, but obviously it opens like that. So that's how you graph those. You kind of use your asymptotes and your vertex to direct and guide you, and your foci should be look like they're going to be squeezed by it. Any questions? So what are the vertices in this case? And how is this going to open? This number 16.
Horizontally?
It's going to open horizontally. Good job. Because the X is in the first position, and that tells us where our vertices are. So this is plus, minus, 2, 0. And then vertically, we have the co-vertices are going to be 0 and then plus or minus 3. Draw your little rectangle and your asymptotes. This is such a struggle for someone who doesn't draw. Campbell, you're an artist, aren't you? Is she still with us?
No, ma'am.
Oh, she's not. She left. She gave up on us.
Yes, ma'am.
Okay, so we've got 4 plus 9, which that's going to be 13. So C equals 13. C squared equals 13. So C equals the square root of 13, which is approximately 3.6. And since our vertices are in the X position, our foci are going to be in the X position. So we've got plus minus 3.60. So that's going to be roughly right here and right here. And then the parabola is going to open like this. Is Walker still with us?
Yep.
Is this helping you, Walker?
Mm-hmm.
Okay, good. All right. That's how you do that one.
Okay.
This is the one that I was hoping Campbell would stick around for, because we're going to work backwards on those parabola equations, because this first one is a parabola. The vertex is at the origin, so that's a giveaway that if it's got a vertex and not a vertice, that you know for sure that it's a parabola, because the other conic sections have multiple vertices. Does that make sense? So if it's going to be at the origin and the focus is in the Y, that tells me that this is actually going to open vertically, just like the other one that we did. So the equation that I'm going to be working with is going to be the X squared equals 4py. And what I know is that P equals -5, because that's what the focus and the directrix. So remember, the focus would be 0, -5, and the directrix in this case is going to be Y equals 5, the opposite. So if P equals -5, then what I know is that 4 times -5 equals, or -5y. X squared equals 4 times -5y. So that means X squared equals -20y. And you're done. This one is a circle because I'm given the center and the radius. So if I'm asked to write the equation where the center is 0, that's x squared plus y squared. And then I'm going to take the radius and square it, and 15 squared is 225. Any questions about those? Are y'all good on these? Do I need to keep going? Or should I go to a different worksheet?
Could you do 19?
Oh, absolutely.
Okay.
Okay, so this one is an ellipse. And what I know about an ellipse is that that the vertice is going to be in the larger, its position doesn't matter, but the vertice is going to be in the larger, the bigger, like the bigger quantity. And since it's in the y, it's going to fall under the y. Does that make sense? The vertice always tells me it's the largest value, because in the ellipse, it's value that makes it the vertice. And in the hyperbola, it's position. And the value, this tells me that 64 is the largest value, and that since it's falling in the y, it's going to go under the y squared. But in order to find the x squared value, I have to fill in the foci, or fill in the equation of the c squared equals a squared minus b squared. So 4 times the square root of 3 squared is 16 times 3, which is 48. Do you all understand that?
Yes, ma'am.
Okay. And then 64 minus b squared. Okay. And so I'm going to subtract 64 from 48. I did this already earlier.
Is the test going to have problems like this on it?
Yes.
Okay. Do you know roughly how many questions it's going to be? Like, is it going to be like 30?
It's going to look like part of this review.
Okay.
It's going to look like the worksheets that you've had and perhaps this review.
Okay.
So this is going to be negative 16 equals minus b squared. I would divide both sides by negative 1 in order to remove my negative. And I've got 16 equals b squared. And that goes right here. So there's my equation. But you'll be able to use your notes.
Okay.
That's why we're telling y'all to make sure those are filled out.
So you can use the
Cornell notes.
The Cornell notes. You can use the like the ellipse and everything that we filled out in class.
Yes.
Yes. Yeah. Okay. Good.
Okay. And are we going to have to turn those in as well?
Yes.
Okay. Well, you already know the situation with those, so they're
I
definitely.
don't care if it smells like coffee, and I was actually able to get you 3 copies. I was not able to get you 8.5, but I was able to get you the others, but I really don't care if it smells like coffee. I love coffee. Coffee makes me happy, particularly
Okay.
first period.
Okay. It's just more like you can read them. It's just, I don't know, but I'm definitely going to use those other copies if you don't mind.
No, yeah, that's fine.
Oh, awesome. Are you going to email them to me?
I did.
Oh,
They should be sitting in your email right now.
let's see.
Are they?
I don't see them, but let me reload it and see.
Let me make sure I hit send.
No, ma'am, they're not here.
Oh, yay. Well, there you go. All right. Well, I'll make sure that I send them. All right. On the, let's see. On this last one, it's a hyperbola. So you've got the vertice, which in this case, it's in the x squared. So this is where position matters. And the vertice is in the, is 5, 0. So that's going to tell us the x is going to go first. So that's 25. The middle operation is subtraction on a hyperbola. And it always equals 1. And in order to find out what this b squared is, I've got to use the Pythagorean theorem, essentially. And that's the square root of 61 squared is going to be 61 equals 25 plus b squared. And I'm going to subtract 25 from both sides, and that gives me 36. So 36 equals b squared, and that's my final answer. Any questions before I move to 8.4?
No, ma'am.
Okay. Do you want me to graph a few more ellipses?
Sure.
Okay. All right. Once
Just
again,
like 1 or 2 would be perfectly fine for me.
okay. We'll do the first one. On 30, we've got 36 and 25. And then we're also supposed to identify the vertices and covertices. So the vertice, once again, for an ellipse, it's value. So you take the largest value, and in this case, 36 is bigger than 25. So the vertices, and they also fall in the x. So the vertices are going to be in the x position. So it's plus or minus the square root of 36, which is 6, 0. So my vertices are going to be here. And then my co-vertices are going to be on the y-axis, and it's going to be the square root of 25. So the co-vertices are 0 and plus minus 5. And then the foci is c squared equals a squared minus b squared. So 36 minus 25, so that's 9. So my foci are going to be in the x position because my vertice is in the x position, and it's the square root of 9. So there's my foci. And that's such a beautiful ellipse. Oh, I totally didn't subtract this right. Why didn't y'all tell me? Y'all just took my word for it. I was like, something doesn't look right. Foci were too far away. So the square root of 11 is roughly 3.3. So it really wasn't too far off, I guess. Sorry about that. Okay. Now I'm going to go down. I'm going to skip down to number 3 because it's a little weirder.
Okay.
Because of this, but that tells me that 9 is the larger because this would be an understood over 1. So the square root of 9 is 3. So my vertices are in the x position, so they're plus minus 3, 0. And my co-vertices are 0 and plus minus 1 because the square root of 1 is 1. 3, 3, 1, 1. And to find the foci, we've got c squared 9 minus 1. So c squared equals 8. And the square root of 8 is 2 point something, I think. So my foci is right here and right here. I have 2 times the square root of 2 as my foci. I don't have, does anyone have their calculator to do the square root of 8?
I can do it.
So that we have an exact right here.
It's 2.82. Well, 2.83.
Okay. And so how do you feel? You feel good about graphing number 2 and 4 by yourself? Everybody?
Yeah.
Okay. All right. To write the standard form of the equation of the ellipse below. Okay. Once again, on this one, it's size that matters with regard to where the vertice falls. And so that's telling me that the vertice, that the vertice is going to be 100, is 12, 0. So, and it's in the X. So that tells me that it's going to be X squared over 144, because you're going to put the largest value underneath the major axis. That's where the vertice falls, is on the major axis. So the major axis in this instance is going to be underneath the X, because of 12 being in the X position. Does that make sense to you all?
Yes, ma'am.
Okay. And then to find what goes underneath the Y, once again, we're dealing with an ellipse. So we've got C squared, which is going to be 100 and the square root of 119 squared, which is 119, equals 144 minus B squared. So I'm going to take 119 and subtract 144. That gives me negative 25 equals negative B squared. I'm going to divide both by -1 to get rid of the negative, and that's 25 equals B squared. So that goes right here. All right, can you all tell me? I know that my center, X squared plus Y squared over something equals 1. Where are my vertices going to be in this one? Where is it going to, which
Y.
variable is it going to be underneath? Would you say Y? Good job. And what is it going to be? What is the A squared value?
What's what? Sorry, you keep
What's the A squared value? What goes underneath Y squared?
Oh, 100.
Good job. Does that make sense to you, Walker?
Yeah.
Okay,
Yeah.
good. All right. So how do I find the B squared?
Plug it into C squared equals A squared and B squared.
Right. And so I have the foci. So that's going to tell me that C squared is 36. A squared is 100 minus B squared. So I'm going to take 100, or I'm going to take 36 and subtract 100 from it. That's going to give me a negative 64 equals negative B squared. Divide both of those by -1 to get rid of the negative. So that tells me I've got 64 as my B squared. So my equation is X squared plus over 64 plus Y squared over 100.
Okay.
Any questions about that?
Yeah.
Nope. I might have to be logging off pretty soon, so I think I might go ahead and
Okay.
do that. Thank you so much, Miss Sparks. It was really helpful.
Okay, no problem. There's some on 9 and 10 that give you the covertice as opposed to the vertice. Do you want me to do those?
Yeah, I wouldn't mind you doing one right before I leave, so I can kind of.
So let me skip and do that. So let's look at the one that's the covertice. That tells us it's the smaller value, and it's going to be in the Y. So I've got X squared plus Y squared over 4, because 2 squared is 4. equals 1. And then to find what that a squared value is, I'm going to take 2 times the square root of 15 and square that, which gives me...
Should be 4 times 15, right? So
yes. So that's 60, right?
Yep, that's it.
A squared minus 4, because I know that my covertices are my b squared. Does that make sense to you guys?
Mm-hmm.
So I'm going to add 4 to both sides. That gives me 64 equals a squared. So there is my formula. X squared over 64 plus y squared over 4. And so I would essentially do the same thing on this one. My covertices are in the y position. So that's going to give me 25 here. And to find what the a squared term value is, I would square 4 times the square root of 6, which is 4 squared, which is 16 times 6, which is 96. So 96 equals a squared minus 25. Add 25 to this side. 121 equals a squared. Is that making more sense to you guys?
Yep.
And are you seeing the differences between the hyperbolas and the ellipses? That there are differences in their similarities. First and foremost is the sign or the operation that comes in between both of the key terms.
Mm-hmm.
And then the second is that with the ellipse, it's the value of the largest one. It tells you it's the major axis where the vertices are and the foci are. And with the hyperbolas, it's position that tells you where it is. And whatever is in that first position is going to tell you whether it opens vertically or horizontally, determining whether it's an x squared or y squared value. And that's also where the foci is going to be.
Mm-hmm.
Okay.
All right. Well, I gotta go. Thank you so much for Sparks.
No problem. Did anybody else log on, Adriana?
No, ma'am.
Do you want me to do a few more, or do you have some more questions? You want me to go over some parabolas?
Sure.
Okay. Or do you want me to do a few more of these?
Can we just do like number 11, I think?
Okay. So it's a covert that we're given the information of the covertice, and it's in the x position. So that tells me that I've got x squared over 25 plus y squared equals 1. And then I need to find out what this is, what that value is, what the a squared is, because the a squared is the vertice. The b squared is the covertice. So the foci is the square root of 11. So the square root of 11 squared is 11. So that's our c squared term. And then the covertice is the b squared. So I've got a squared minus 5 squared, which is 25. So I'm going to add 25 to both sides. So that gives me 36 equals a squared. So the 36 goes right here.
Okay, that makes sense.
It does?
Mm-hmm.
Okay. You feel like you could do number 12 on your own?
I could try.
Okay, let's do it.
Okay.
Are you working it?
Yes, ma'am.
Okay.
Okay, I think I got it. Is it x squared over 36 plus y squared over 28? Oh, 100. Ah, never mind. Can you explain that then?
Yes, absolutely. When it's a covertice, it's the b squared term, and for an ellipse, the formula is c squared equals a squared minus b squared, and the b squared is always the covertice. So the a squared is the vertice, and the b squared is the covertices.
All right.
So when you're in this case, you were given the covertice. So that's going to be your b squared term. So when you plug it back into the formula, which in this case is a play.
Yeah, I see what I did wrong.
Yeah. I think you probably subtracted 36, correct?
Yes.
So if you were working with the vertice, you would have to subtract. But since you were working with the covertice, you needed to add. Does that make sense?
Yes, ma'am.
Okay. All right. You want to go work on some parabolas? How are you feeling about circles?
I really don't know how I feel about any of this, to be honest.
Okay.
Yeah, I'm not feeling as strong in this chapter as I have in the past.
Yeah, conic sections can they can be a bit intimidating. That's for sure. But I think you should be good with your notes.
Let's hope I can read them.
Yeah. Well, I gave you the other three. The only one you won't have is the hyperbola one. Miss Stone actually cut and paste that one for us. I did all the cutting and pasting because what we needed to do, we had to take out all the examples that didn't have zero as the center. Mm-hmm. So we kind of had to create our own.
Well, that's the one that looks the best, so that's not a problem.
Okay, well, good, because I should have actually sent those to you while you were working that.
Well, I haven't gotten them, so
yeah, that's what I'm saying. I'm
my bad.
Resending them, but I should have done it while you were working that other thing.
I already have this worksheet done.
You do?
Yes, ma'am.
Does it make sense to you? Should we?
Let's see. My allergies are like making me feel disgusting, so I don't really know what I remember at this point.
Because yeah, I was gonna say you and I actually did this one together. But what am I sending you again? I'm like, help me. Oh.
I think I understand this.
You do?
Mm-hmm.
Just maybe need to look back over it or something a minute.
Maybe. I'm trying to see if there's anything that I don't have done. Because I think that's where I feel a little bit better with that and with circles, so like better than on the other ones.
Okay.
Yeah, I think I have just about everything. I just have a couple of problems on 8.4. And like, I think that's it really.
All right.
I need to double check. I think that's about it. But I can probably figure those out.
Well, you can always email me.
Okay.
And if we can always do a Google Hangout if we need to too.
Yeah. I'm like so nervous for the test quiz thing.
You know what? You're going to be so pleasantly surprised if tomorrow, honest. You really will.
I usually just feel stronger about it.
Yes. But hang on just a second. But as long as you bring those notes and the worksheets done, you'll be golden. I promise. And I don't promise very many things. But you will, as long as your stuff's filled out.
Okay.
And don't forget to print that assignment sheet.
Right.
But and bring your coffee stained copies.
Okay.
All right. I sent them.
Okay. That sounds good.
It's
I'll let you know.
8.2, 8.3, and 8.4.
Okay. Thank you.
Not a problem.
Okay. I think I understand everything.
Okay, so you got and you have all the worksheets completed?
For the most part, yes, I have.
Because I was going to say we did 8.2 together.
Yes.
And did we do 8.3?
I don't I see if what even happened to that one? Hold on. Because I know I had it here a second ago.
And we did a good bit of 8.4 today.
Yes, ma'am.
And then I think we did a good bit of 8.5 as well.
8.2. We did 8.3. 8.2. Yes, ma'am. I just have like a couple of problems that I haven't finished, but it's okay.
On 8.3?
8.4. And I think that's it.
Okay.
Not 100% though. Yeah, I'm pretty sure that's it.
All right. Well, if there's something that you want me to do with you, I will.
Can we quickly finish up 8.4? Do you mind?
Yeah. Which ones do we have left?
2 and 4, 7 and 8.
Okay. So on number 2, which one would be my vertice?
The X, right?
Right. And they're going to equal what?
7.
Perfect. Plus minus 7. Because I'm going to go up 7 and down 7. Oh, and that's not even on my X. I mean, that's Y. I'm going to go over 7 left and right. Over 7, right 7. And then my co-vertices are going to be 0 plus minus 2. So my foci are going to fall on my major axis, which my major axis is what?
X.
Right. And I find my foci on an ellipse by the somewhat Pythagorean theorem, but not really equation. So, and then I have my 49 minus 4, which gives me 45. So C squared is 45, and the square root of 45 is
6.7.
I'm sorry?
6.7.
Okay, 6.7. Thank you. And that's going to be plus minus 6.70. And it's always eerily close to wherever your vertices are.
Okay, I was wondering because
It's
I was like,
always hard to see them, but that's, I swear, they're on there.
okay,
All right, so number 4, our vertices are what?
5
They are 5, and they're on which axis?
x.
On number
X,
4.
right? No, y. My bad. Sorry.
Not a problem. I knew you would catch it. You and I are like that. We say it, but we know what we're doing.
Yeah,
We just might not say it.
I can see it. I just can't speak. You know,
I'm right there with you.
the struggles.
Yeah. All right, and so the co-vertices are plus minus 2, 0. And our foci are going to fall on the y-axis this time because the y is, is the major axis.
Mm-hmm.
And we find it by c squared minus your a squared, which in this case is 25 minus 4. So c squared equals 21. And the square root of 21 is, what is the square root of 21?
4.6.
I'm sorry, 4.6?
Yes, ma'am.
Thank you.
Mm-hmm.
And like I said, it's going to be on the y. So once again, it's eerily close to the vertices, so that's weird. But they're there. I promise they're there. Just looks like I colored right over them. All right, which 2 did we not do on this one?
I think it was 7 and 8. Let me check. Yes, ma'am. It was 7 and 8.
All right. So the vertices, we're given the vertices. And what position are they in on number 7?
Y.
Okay. So that tells me I'm going to have x squared over something plus y squared over 25 equals 1. And the foci is 3, so that tells me it's going to be 9 equals 25.
1 sec. Okay, my dog decided to go insane. My bad.
Oh, that's okay.
Okay,
I
sorry.
have dogs. I get it.
Yeah, hush jingles. My word. Okay.
So, so in order to find the b squared or the co-vertice value, or the value that goes underneath the x, I'm going to use my c squared equals a squared minus b squared formula and plug in what I know. And I know my foci is the c squared, so I'm going to square the foci value, which is 3. So 3 squared is 9.
Mm-hmm.
And then equals, and then 25, which is my vertice squared,
Right.
which is my a squared.
Mm-hmm.
I sent her a text today.
Hang on just a second. Miss Stone is asking about her students.
She, so far, I haven't heard, she hasn't texted me back, so.
Okay, so I've got 9 equals 25 minus b squared.
Mm-hmm.
So I'm going to subtract 25 from 9. And that gives me negative 16,
Mm-hmm.
which equals the opposite of b. Divide both sides by negative 1. And that gives me 16 equals b squared. So that's going to go in this position.
Okay, that makes sense.
All right, on number 8, once again, it's the vertice, and the vertice is in what position?
Y.
y. So I've got x squared over, and then 14 squared is 196, I think.
Yes, ma'am.
And so I've got the foci squared is going to be 49 times 3, which is 147, equals 196 minus b squared. So I'm going to take 147 and subtract 196 from it. That gives me a negative 49 equals negative b, or the opposite of b.
Mm-hmm.
And I'm going to divide both sides by -1. And that gives me 49 equals b squared. So that would go here.
Okay. I actually, let me see. I'm looking at the 8.5 worksheet.
Yes, ma'am.
And yeah, there are a few that I don't have done, but I think I'm going to try them on my own and see how I do. I'll email you if I
I was going to say, email me if you cannot do them. And I will either email you pictures back, or we can do a Google Hangout. Your pick.
Okay, thank you.
Okay, because I can do a one-on-one Google Hangout with you if we need to. Okay.
Well, I know that you have lots of important things to do, so I'm going to try to figure it out. And then if I can't, I'll let you know, but I don't want to bother you anymore. So.
Oh, that's okay. I'm always here if you need me.
Thanks.
All right, sweetheart. Have a good evening.
You too. Thank you very much.
Bye-bye.